Okay, let's get back to the lab, I guess.
Yeah, so Mark, if you were mentioning, you were talking about the ARV. I am probably the most ignorant person on this call, but I'm used to that. So, ignorance is my specialty. Um, so with the ARV, how is that? Are you just kind of speculating that that's related to the Alzaphon experiment, or was there kind of a connection that
uh,
pushed you that way?
there is a connection, and it is basically the fact that there is an aluminum flywheel inside of an electromagnet, and according to Alzaphon, this should create dynamic nuclear orientation.
Well, now, if it's okay, and I want to, and again, I do the ignorant questions that everyone wants to ask, and I get to be the dummy. So, um, what is it about the Alzaphon experiment specifically? And the reason I ask that is, as we all know, there are probably 1,000 different ideas for anti-gravity. What was it that pushed you towards Alzaphon specifically? What is it that makes this the one for you?
Okay, well, there was a lot of this the ones before it. It's just my method of attacking the subject. I've gone down your path and tried the ion craft, and I even designed a new form of an ion craft, which is basically a ball on the bottom with a straw, and then you put the wires on top. It literally, a 5-year-old can build it. And my daughter, we actually had a whole bunch of kids over at the house, and we took out all the bowls, and you cover it with aluminum foil. You just press down the aluminum foil. You stick the plastic straw in, put the fine wires, and then we stuck it inside the Faraday cage, and we saw which ones flew the best. It was like a competition. It was a lot of fun. But yeah, I tried that, and then I tried pulsing the high voltage DC. That experiment was done very rudimentarily in my garage. I was working late at night, and I had this tiny little Faraday cage, and you could smell the ozone coming off the thing every once in a while. I had to open up the doors, and I basically hooked up a whole bunch of vacuum tubes. I actually have a mock-up build of this circuit right over here. And this circuit actually is in working order right now. What you got here is the high voltage line that comes in. Now, because we're using a triode vacuum tube and we're trying to max out the voltage, everything needs to be insulated, and everything is going to be high voltage as well. So this is coming in here, and there's a lithium battery that powers the whole thing, and that goes to 3 different probes. This is a DC to DC converter, which ups the voltage for the grid, and we need a negative voltage, so that's negative to the ground. And this is a DC to DC converter for the 6.3 volts to run the element. And this over here is like a fiber optic receiving chip that I added a MOSFET to, so that instead of it's a high voltage MOSFET, pretty fast.
Is this for Alzaphon?
This is no, this is for pulsed capacitor experiment.
Right. So back to the question of why we picked Alzaphon. I think we're just trying to knock out all the low hanging fruits.
Okay, so this is actually not a low hang. This is an experiment that I actually haven't finished yet. So I'm just trying to tell you what I was trying to get to is that there's many different experiments that we would like to try. Alzaphon. I first found out about it by being on Jeremy Riss's channel, and somebody posted it in the comments. They posted a link, and Jeremy Riss never heard of it before.
I'd never heard of it either, to be honest. That's all new to me.
Yeah,
but Ron has, but Ron's heard of everything. So,
I don't know. Ron, did you hear about it from me, or have you heard about it before?
He said he knew some guys from Penn State. Ron, your mic's still muted.
Ron, you're muted still. Yeah, again, he was at a hotel. He was talking about a hotel in 1981, I think, where they were talking about it. So.
Oh wow! So yeah, he definitely knows the ins and outs of that.
Yeah. No, it's new to me though. I think I've seen references. I think I may have seen the name, but.
Well, there's something called the Stirnemann, STIRNIMAN, Stirnemann anti-gravity list. It goes back to Usenet. Do people remember Usenet? Usenet was bulletin boards before the World Wide Web existed. They're still there,
How do you
buried,
spell Sterneman?
Stirniman, Sterneman anti-gravity list.
So getting back to Alzafon, what I found in Alzafon is a explanation that just made the most sense. It was the most coherent, explanation to what is actually going on. And it explained a lot of the phenomena that we see, such as, the craft is waving around a lot, and it shoots off with a flash of light. So I'm thinking, like, if you make the craft almost weightless, what are you going to expect? Like, it's going to need a very accurate thrusting system. So it might, sweep around a bit, or it might use light as a thrusting source. So you see the craft, like, it's hanging around there, and then suddenly it flies off at a great speed. Why is that happening? So what I'm thinking is happening is they're building up the dynamic nuclear orientation in the craft so that it's coming closer and closer to absolute zero. And then they're you're just turning on the lights, and they go flying off at a crazy speed.
Oh, well, can I interject? Am I online?
Yeah, you
Am I
are.
visible? What I wanted to say is, I guess everybody here knows about the RB-47 incident. No?
I'm not familiar with it, no.
Everybody here should, the source for Alzafon, the background, how Alzafon got into this, was something called, you can go online. It's called the RB, which stands for Reconnaissance Bomber -47 incident. It's available at the blackvault.com, a UFO site. It has the origin of the frequency. The RB-47 was an AWACS plane that recorded all the signal intelligence that Paul Murad knows about. The signal intelligence of a UFO was recorded over Meridian, Mississippi. They saw it on radar. They took all the radar downloads. It became secret. It got leaked out at an AAS meeting up in Boston about 10 years later. Somehow Alzafon got wind of it, and that became the basis of the Alzafon experiments. It was based upon a UFO observation by a precursor to an AWACS airplane.
Oh yeah, I read that in the book. Actually, it was pulsing at 2.995.
Yeah. It's all there for those who don't know where it is.
Right.
But that was the introduction, and I don't like the word reverse engineer. I find that just overused. But in terms of, for those who don't know the origin of where Alzafon came from, and so that's all I wanted to say for now. So.
Oh, yeah. So thank you very much for that. Yeah, that AWACS plane interaction really, showed that something was going on. It was pulses of like every 5 or 6 milliseconds at the 2.995 gigahertz. And that sort of like brings up Roswell, if you think about it, because they were playing around with interesting radar back then. And what is radar? It's gigahertz frequencies. So if you're able to disrupt whatever's going on in the craft, then maybe you can actually bring it down. You can make its weight rise and rise and rise until it has to hit the ground.
Well, what I want to add for a second, are you familiar with the photographs of Rhodes of the UFO after Roswell? There was a UFO over Phoenix that Rhodes had 2 pictures of that took place about a week after Roswell in 1947. Are you familiar with that?
No, I'm not familiar with that.
I'll give you the website. The website is for FORE Shadower, SHADOWER.net, foreshadower.net. And if you go to Google Images and type in Rhodes UFO Phoenix, you'll get the 2 pictures of them. And it was, so in terms of actually, I was never a fond of Roswell. But when I saw the photographs that were taken a week after Roswell, it makes you think. I mean, it's the only thing that, in terms of discrediting Rhodes, a lot of time was spent by all the government agencies to discredit him, even though he worked. I guess the name Lee DeForest doesn't mean much to people nowadays. He was 202 patents. He's the father of radio. So, But anyhow, that's my link. So
Oh, okay. So what I really liked about the Alzaphan experiment was that just made sense. It made a lot more sense than the other theories. What I was getting to with the impulse thing is I actually came to this conclusion with the conversation with Jeremiah that really what I'm dealing with there is actual thrust. It's a thrusting device. It's not the inertial mass cancellation thing. It's not going to get you into the air. What the most important part really is the dynamic nuclear orientation aspect. So that's where I decided to put all my research. Jeremiah has a lot of experience with high power electronics. He's been playing with the brute force method of anti-gravity, and he sort of came to the conclusion, and to me it makes sense as well, that when you're dealing with high pulses of energy, you are getting pushed, but it's more of a thrust. It's more of an electron rocket that is being created that allows you to push.
Well, I mean, let me just change the term electron rocket. It's not ejecting electrons. It's using fields, the fields generated by the motion of electrons and the fact that they take a transit time to move from one place to another in three-dimensional space in order to produce a unidirectional force as a result of a phasing of these individual fields.
Okay, yeah, fair enough. So we're actually thinking of trying an experiment like that where we're going to have a capacitor bank discharge into another low voltage empty capacitor bank using a thyratron switching system to get the maximum impulse. And we can hang the entire thing up here in the lab and see if there's any actual movement, and also check for ion wind at the same time. And I think that would be a very interesting experiment to try. We'd probably use the same circuitry that I had for that system, so you can have like a remote control and really maximize the tubes. But yeah, getting back to Alzaphan, the reason why I was so excited about it and my excitement kept on building was that it finally made sense. Here was something that explained everything away. It also explained where science went wrong, and
Steinmetz went wrong, you said?
Yeah, science went wrong with the whole concept of warp space.
Oh, science went wrong. Sorry, I thought you said Steinmetz. My bad.
No, science went wrong. Newtonian mathematics and the warping of space mathematics actually come out to the same answers. So it's all a theory. And I'm sure Todd can get in on this a little bit more later. But basically, Alzaphan is thinking of the universe in a totally different matter. He doesn't really think that space is warped. He thinks that matter itself isn't constrained to the tiny dot where it is. It actually moves out for the entire universe. So it's literally the definition of infinity. It's a single spot, but it's also connected to the entire universe. So
quantum non-locality.
Quantum, you can call it, there's probably a lot of different names for it, but yeah, that everything is connected on this fundamental level. And that really connected with me because it suddenly made sense. And when you have these two atoms that are connected to each other, they're going to want to come closer based on the way water acts in space. When it comes into contact, you have surface tension, sort of wants to clump together, and that's really the source of gravity. But these subatomic particles can only interact with something that is of their same spin. Otherwise, the fields wouldn't interact correctly. So that's where the dynamic nuclear orientation comes in. There's actually many different theories for the same experiment that would explain Alzaphan. And I'm not really set on any one of them. We're just trying the experiment to see what happens.
Right.
Yeah, well,
we can tweak it.
I think it's interesting too. I mean, it matches a lot of the other ideas, right? I mean, it's a lot of this stuff is almost kind of like, you just have to look at like the aggregate of all of these different experiments and all of these different ideas. And it's like, where does that aggregate kind of go? And so it seems like it kind of fits with that aggregate. You're talking about spin, you're talking about fields. I mean, these are, yeah.
It's a very interesting aspect of science. And when you look into it, you find that the information that is necessary for this research is very hard to find, and the people who know about this stuff are very far. They're pretty hard to find. People that actually know about this stuff.
Yeah, Mark.
like EPR and NMR.
Mark,
Yes.
can I jump in here?
Go. Sure. Go ahead.
Yeah. Yeah, I've done a lot of work with what are called PCMs, phase conjugate mirrors, for electromagnetics. And it's the one area of research where it just isn't allowed by the NIH. You know, I remember seeing a document back around 2005 forbidding research in electromagnetics, you know, for these type of power systems. But that's the whole key to anti-gravity. Okay.
What
When
kind of
Tom
systems?
Beard spoke about this back in the 90s, and he said that when you have a large-scale negative energy effect, it automatically leads to a large-scale anti-gravity effect as well. And when I look at this ARV, I'm not seeing it. Okay, I'm not seeing a large-scale negative energy effect, which is what you got to have to do anti-gravity. That's the bottom line. Okay, so I'm working on systems to develop anti-gravity using large-scale negative energy effects. Okay, so when I look at the ARV, I'm not seeing it. Where's the negative energy? Okay, if you're going to do anti-gravity work, you got to work with negative energy. Okay, and that's where you set up opposing fields. You have to have broken entanglements, opposing magnetic, preferably magnetic fields.
Oh, Will, there actually is information on that specifically from interviews that we've done with David Elzafon, which is Frederick Elzafon's son. And in regards to the opposing magnetic field, so we first set up a fixed magnetic field, which is fairly laminar as we can possibly humanly get it. And what we then do is inject microwaves at an angle that will disrupt the magnetic fields of the material inside that sample that we're testing.
Yeah, that would be torsion.
Right. So the disruption basically wiggles those fields around, and it causes them to become displaced. And the basic theory is, and I'll oversimplify it here, but the basic theory is you disrupt these magnetic fields, they decouple from the gravitational field as a result of the energetic state that they're in, and they're a very large amount of motion compared to the normal rest state. So they're moving basically so fast as a result of these fields that are precessing them that they are now disrupted.
Yeah, you got to twist the field. Okay.
Can I add the point? Can I ask my point that I asked previously? The thing is with the ARV is you're generating an electromagnetic field with that sliced piece is there, and you've got that toroid, and that's generating another electromagnetic field. So you do have electromagnetic fields against each other, which is what you're suggesting you need for negative energy.
Okay, and then you got the capacitor on the bottom to set that up as a resonator. So you got a PCM resonator effect going on there. That's your negative energy, and that's what you need to do anti-gravity.
You broke the code, but I sort of disagree with your viewpoint that the only way you can do this is with anti-energy. And I think we got to look at it a different way also.
I think that's an interesting point that you brought up, William. And that's something that we can try in the coming months when we get everyone here in the lab. So we could try a parallel plate capacitor impulse, because I really think this is about impulse. It's about wave shape. It needs to be like a slanted sawtooth in order for it to work properly. You need to have a much...
Tesla in his original magnifying transmitter was a switch mode power supply. He's probably one of the very first ones to do it. But then he set up his opposing field action as PCM using opposing magnetic fields, and then he had his capacitor network, and his load was his output transformer. Okay, so he was working with PCM.
He did call it with the magnifying transmitter. It was really a switch mode power supply. When that thing would channel ions down, there was a delay between the output field and the ion drift going into that potential. So once the ions were established and they were inflowing into the opposite potential set up by the magnifying transmitter, they would enter the circuit and be fed back into the generators.
No, if I could jump in, Bill. So Bill Alec is an electronics engineer, and so he's actually building these experiments too. I don't know if you've built this one, but Bill is building stuff as well. So Mark, when you talked about doing experiments, that might be something Bill already may have experiments, or he may have models, or something like that.
I'm very curious, Bill, about what you're saying, because I've studied this quite a bit from the perspective of Tom Bearden, and he talks a lot about negative energy as well. And I have a DVD about where he talks all about negative energy flows and Floyd Sweet's vacuum triode amplifier,
Right.
and how that thing, when he put it under load, it just lost weight and levitated, and it got cold at the same time. And it got me thinking about the negative energy and how that ties into the Alcubierre warp drive. How in his equations it requires negative energy to create kind of an expanding space. I guess that's how they explain it. But
Mhm.
Yeah,
so
you know, if
the Dirac C, the negative electron holes in space
Right.
and stuff like that. So yeah, interesting.
So now, in terms of the Alcubierre drive, I read something about that. I think this might have been Eric Davis who said that. But what he had said was because the need for negative energy in that case was massive, right? And it was like we can never achieve all of this negative energy. I remember reading something that had said if you spin the fields, the spin basically reinforces the negative energy. So you can use the spin to reinforce that. And
Right. Yeah.
So
It's called the Barnett effect.
okay.
So what I was saying is,
Put a link on the chat board here.
so what I was saying earlier is that we're going to actually be trying this experiment to try to pulse these parallel plate capacitors. And one option would be to have an electromagnetic coil, maybe at some distance or right on it or across it while we're pulsing it to see if that creates, a bigger effect. A bigger or smaller.
Well, you need a large-scale negative energy effect, which of course leads to a large-scale anti-gravity effect. Bearden actually said that in his lectures. So back in the 90s.
I had a question related to this for Ron. Back to the materials side of this stuff and what kind of materials we can use to basically produce these negative energy states. What did you think about the U.S. Navy patent there by Sal Pace, and that was talking about that? I think it was a type of zirconium material. It was similar to. It was a piezoelectric effect that they were using to generate room temperature superconductivity, and room temperature superconductivity that could be generated by using these piezoelectric materials and squeezing them to produce these negative energy states that, like what I use the condensed matter term for them, which is polaritons.
Well, I want to say, I think it's some of these materials. I was in contact with Sal Pace before he got clamped down upon. And I guess he's down in Hampton, Virginia, Hampton Roads with the Patuxent Naval Research Center. And anyhow, piezoelectric materials, I tell people what makes our cell phone work is the piezoelectric in a cell phone is an electret. It's a mylar material. And so in terms of having a polarizable material, they have to be quartz. If you look at chiral quartz, by virtue of a lot of your early frequency, a lot of your early electronics, your early microphones, quartz goes way back into the history of electronics. And so when Sal Pace got into piezoelectrics, I go, well, when you're dealing with piezoelectric, you're breaking symmetry. And that's what you need for these devices, is simple breaking of symmetry. I don't know where, but I think it was diselenide. It was a zirconium diselenide. There's a whole series of diselenides. So that's all I can say. What I wanted to interject here, when you were discussing waveforms, if you look at the patents, the nonlinear electromagnetic propulsion patent of Colonel Rex Schleicher, you will see in there, he has a dedicated, it's not quite a sawtooth. You might want to look at the waveforms. If you're interested in waveforms, look at the waveforms of Colonel Rex Schleicher's patents. It might give you an insight. It's something I don't do, and that's all I can say. It might be helpful. That's as far as I can go.
Well, thanks for that.